Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Today I will talk about techno-economic feasibility of biomass gasification for the decarbonization of energy-intensive industries. The work is written by Professor Clara Jarota Cordoba from Zaragoza University from Spain, and the work is published in recent number of energies. What is the reason of the work? The reason of the work starts that we need to limit our carbon dioxide emission due to European Union, because European Union and Paris Agreement for 2017 that would be reached from up to 2031, 2030. It depends of country, because the same depends of China and India and Iran. And these he says that some section are very hard emissions, and as example, which are most emissive, give iron and steel sector, because steel we need it, and generation of steel requires much more carbon in mining and in processing. It requires steel manufacture, requires steel temperature 1600 temperature. One of it is made for is coke. Coke can be from coal processes by heating coal in an oxygen atmosphere up to 1300. But this is responsible, this coke process, for 40% of water emission, carbon dioxide emission. Therefore, if we should reduce this, we reduce this carbon dioxide effect. And we need to change the limit, for example, for renewable, for example, for biochar. There are several types of biochar, from biogas, from biomass, and mostly can be by pyrolysis or gasification. Gasification is thermal type of pyrolysis sometimes. So, for example, some others say that different, which requires heat and additional oxygen, which will produce some troubles, which I will say later. And the work is showing free bibliographic survey. So what was done in our few times, and show which version are more suitable to European Union requirements for char and fuel gas, and how these measurements are reliable. The methodology is first comparing cost of production of several biogenic sources biogas production and feasibility in the market. So how can is the substrate available in all countries or some, or is better to be used in one region or other region? And fossil fuel are still mostly, and they produce a lot of carbon dioxide, but we still need some some replacement due to depletion of coal and oil and coal and natural gas. So the mass analysis we calculate in comparing the energy output compared to natural coke substitution potential. So how it compare is using. And by profitability and results. The production of biochar cost per kilowatt hour from 0.03 euro to 0.04, and this vary. The biochar classification can vary so from 10 to 200 gram biochar per gram of biomass. This situation is different because they sometimes can be by waste tires, which are also some not maybe biomass mostly, but synthetic uses polymer, waste polymer that can be recycled. And some part of waste tire are natural synthetic gas, so part is biogenic, partly, but mostly synthetic. So they added in here as for bio process also some biogenic processing, some material which are usually not included. So this is showing the syngas calculation and still making process. How can be replaced? And we need in 2020 cost of carbon dioxide trend of increasing from 25 euros to 84 euros in 2022. And this year, with some reduced to 72.4. So this increasing cost of carbon dioxide, and this is emission cost. The highest emission cost is from natural gas cost emission highest carbon dioxide, 2 times less costly than production with coke and coke. And this how is this is production energy cost capacity, and energy cost capacity in will be according to cost would be less because higher and more due to regulation and necessity to reduce carbon dioxide emission. This is natural gas output or biochar output in 3 times, substitution potential natural coke, and this is showing that the highest biogas output of biochar was obtained of biochar of only 700 ton per year was more suitable, and coke substitution was less, and biomass input was case scenarios from 1,000 input to 20,000 in 4 cases. 2 was 5,000 and 10,000, and this 10,000 input of feed rate 1.43 was this giving the highest gas output to biochar output. And this cold substitution was more similar, and but cost were for carbon related savings was highest in the more biomass input. So this is total saving in case of 20,000 kilogram per year would be saving 3 billions of euros. So the saving can be different than gas output reasons, because the highest was this gas and efficiency was the free, but high reduction of this biochar was most sufficient in cost. So this is the what we better here we see more with less efficiency, but it repay better in case of Europe. The economic parameters are in case of the highest was a total of 75, so 10,000 was a total 75 kilograms for a residue and fed to bubbling fluid as gasifier, when in case of less was wood chips in case of 10,000, in case of 5,000 was a total of 100 regasification system fed with woody local biomass coupled with with combustion engine, and the least was a total with fed to bubbling. That's bad biomass classification. So we see that difference is, of course, lack of the different of apparatus used and how it's paid back. The payback was in year in case of the 4 scenario. In case of 20,000 was payback after 8 years, after 7 and 5 years, which is little bit less than in case of 5,000. Most expensive was the scenario with using 10,000. However, was highest conversion of biomass and high energy. The total apparatus requirements was higher than for funding. So this is the showing that the crucial development is apparatus also and cost in this size. Sometimes this is the trouble, and we see what the different requirements meets with this biogasification. They don't say about troubles that biogasification also produce some oxide more than pyrolysis, which needs to be separated and utilized because are dangerous. So the work saying also only on economic feasibility, but not saying about risk, more risk and gasification, and how to prevent them. Thank you very much for listening to me.